So as is par for the course, we're just going to, many of my courses, we're just going to upload a last-minute change here. I've very much enjoyed these initial talks, though, and I think they're right in line with what I have to share today. As I'm watching Joe's talk, I'm thinking to myself, I completely agree. It's, you know, what we teach in statistics, we really need to think about this very carefully. I think more of my effort, however, has been not just on what we teach in statistics, but how we teach statistics, which is why I'm glad to follow Chris, because this idea of how do we build quant literacy is certainly the central theme in my talk, too. That's the one? Yes, please. Let you go from there. Can we... And so my story starts around 2011. I was teaching for many years, a few years before that, all lecture-based kinds of classes. And I mean, if I go through my college education, my graduate education, through 50-some classes, I probably had 4 classes that were not lecture-based. Interestingly, I can recall that many pieces of those classes very readily. But in 2011, I ran into, it was a Discovery magazine article, my candy at the end of the day, which had a quote, I'm pulling a few quotes from. A University of Maryland study of undergraduates found that after a physics lecture by a well-regarded professor, almost no students could provide a specific answer to the question, what was the lecture you just heard about? And it went on to say, Wyman, who was Associate Director of Science around that time, himself found that when he quizzed students about a fact he had presented just 15 minutes earlier in a lecture, only about 10% showed any sign of remembering it. And I think these quotes, I still have this article, tore it out, found it before this presentation, and it's stuck with me because I think there's a level of discomfort. Now, naturally, I am a brilliant lecturer, and I have been assured by this by many students seeking extensions on assignments. So I know that's not the problem. But I think my own discomfort was thinking to myself, if I were to ask something that I just presented 15 minutes ago, if I were to give a quiz right now, am I confident that a substantial proportion of my students, let's say just 70%, would be able to answer that quiz and pass it? And I wasn't really sure that my answer was yes. And so that's where my journey on this began. And you start looking into the cognitive science and education literatures, and it's not surprising, and we know this ourselves from our own experience. One of the reasons that all of us are so talented with statistics is repetitive practice. We have interacted with new information, new methods, and we do it regularly. And that interaction produces for us a better grasp of these materials. And so education has tried many things, these learn by doing, problem-based learning kinds of classes, repeated quizzing during class, various activities that are trying to force you to consolidate the information, to interact with the information, more so than you do just with a typical lecture kind of class. And I was all well and good with that literature. You know, that's fine, they're experts and they know what they're doing. I don't know if that was enough to sell me. What sold me was this. This is from a 2011 Science article involving 2 large sections of an undergraduate physics introductory kind of course. It was the second one in their series. And the course went on, as it typically did, as a lecture style for 11 weeks. And in the 12th week, they decided to implement an experiment. And there was going to be 2 people teaching during this 12th week. It's only 3 hours of instruction. One, a traditional lecture given by an experienced and highly rated instructor, and a novel instruction technique given by a trained but inexperienced instructor. And this inexperienced instructor was a postdoc who had only ever TA'd for a class, was only a teaching assistant. So, highly experienced TA. And the race goes. And they quizzed the students after the 12th week to see how much they retained on 12 particular principles that they had been defined prior to the beginning of this experiment. And these were the quiz results. Now, no doubt any one experiment can go wrong, but there are more than a few of these kinds of demonstrations in the literature where the gains of using different techniques for conveying the information produce substantial, like ridiculously substantial gains. We do not need a statistical test here. We can do the, as Scott Maxwell said, the interocular trauma test. Does it hit you between the eyes? And their novel technique was this. It was a deliberate practice technique. The idea was to design questions and tasks requiring reasoning and problem solving in physics, but with ongoing support and feedback throughout the process. And so I decided to try this with one of my classes. I had been teaching an introduction to categorical data analysis for 5 years. It was only lecture. I mean, there was a lab component that was taken care of by the GTA. And the population I'm working with is a mixture of graduate students in psychology, graduate students from other departments, your very unusual undergraduates, but a fair proportion of my class completing a social and behavioral methodology minor. And what I did was this. I reversed the classroom, and I decided to give students most of my lecture materials before class. They were required to watch these videos. The videos were typically 60 to 75 minutes a week, and in order to lessen the burden on myself, what I did was in the final year that I lectured, I captured some high quality screen capture and audio, and I built the videos off of that. So I didn't do a separate recording session or anything like that. And during class, what we did was we met 3 hours once a week. During the first 30 minutes, we talked about the video. We asked questions that went beyond the video. We asked questions that build upon the video. We asked clarification questions. Any questions the students had for about 30 minutes. And then there was a 15-minute quiz. This was kind of just you have to watch the video, you know. And of course, the quiz did 2 things. One, you have to watch the video. You also had to be in class. Attendance was required. Because after the quiz, we spent 2 hours doing exercises. Students broke up into groups of typically 2 to 3. I let them self-select into these groups, and we just did exercise after exercise after exercise. And my role during this, and the GTA role, was the frequent feedback. We were running around the classroom frantically. I will say it's much more tiring than lecturing. I am feeling very bound behind this podium because I know we need the audio, but usually I would be running back and forth across, very active. This was even more tiring. And the idea was this. We were trying to serve 3 roles. One, moving students past roadblocks efficiently. Many of them were unfamiliar with R. So I don't want them losing 30 minutes to looking for the missing parenthesis or recoding a set of dummy codes so that they had a new baseline group. We made those pieces easy for them. We answered questions, which were typically, I would say 80% of the questions were probably on the material, but the other 20% were often students trying to connect to other things they knew, other classes they were taking. How does this fit into a bigger picture of statistics? I would take any question that they wanted to ask. And then the other thing I was doing was, as they completed exercises, going around and asking a few questions of my own to make sure that they were getting key conceptual points that were designed into each exercise. And it's the design of the exercise that was the most challenging part, because what we need to avoid here is the cookbook, as Joe mentioned. And these exercises were often kind of vaguely defined, semi-structured. What I mean by that is, it's nice to have a nice controlled classroom environment where you know what the students are going to do, but I tried to design problems where they could follow different paths, where they could potentially come up with more than one answer. These exercises required many skills. They had to make a lot of the fundamental statistical decisions as to how they were going to look at the data, what they were going to program, even what models they were going to run. They had to do the programming, they had to interpret the output, they had to learn how to communicate the results and write that up as a paragraph for me. And the goal of the exercises was not always apparent from the outset. Often I had ulterior motives in these exercises. And so let me give you an example. It looks very book problem-ish. It starts off with, we have a data set about AIDS, survival of AIDS. We have a drug and a treatment, a drug and a placebo condition. We have their white blood cell count. We ask kind of a vague question, badly worded. We want to do something with, is the drug important here? And most of these questions seem very bookish. You can see that I'm starting to ask them about the odds of survival and what's the Wald p-value, what's the likelihood ratio p-value, what's the AIC, get me some confidence intervals, what would you conclude about the drug's effectiveness? So practicing quite a few skills in one problem. But as you step through this as a student, what you start to do is you first have to read in the data set, which is a surprising it's a roadblock for many students. So week after week, they practice reading in a data set so that they have more confidence doing that. They have to set up the two models. We have one model here with drug and without, if you're not familiar with R. We have a nice healthy deviance difference. There's a nice AIC difference. They look at the regression results, and they see that the Wald p-value is almost as close to 1 as can be. Of course, the R ran with no problems. There are no warnings here. There are no errors. So the computer must have been right. But I'm hoping that you're looking at this, and I suspect that 90% plus of the audience is looking at this and realizing that there's a bit of shenanigans going on here. Because there's something else I'm trying to teach. Because many of them are very trusting of their computers. And they will believe, okay, the computer gave me this, so okay, the effective odds are the effective drug, it's going to be the exponent of 18.29. So the odds of surviving when you get the drug are exponent 18.29 times higher. And then I'll stop them and say, okay, did you calculate that? You really should actually calculate that and write that down. Okay, the odds of surviving if you have the drug are 88 million times higher. And it gives me a chance to stop with them and think about how's likelihood ratio doing the test? How's the Wald doing the test? Why are we getting almost opposite p-values in this case? And we get to talk about things that can go wrong with logistic regression, and that the output doesn't always tell you that. And so sometimes I have ulterior motives in these exercises. I try to teach by experience. Let them play in the sandbox and learn it for themselves, rather than telling them that you can have, for instance, very good separation. And when you have very, very good separation, you can have things like these standard errors exploding, and the computer's not going to highlight that for you. I implemented this in 2013 and 14, 31 students, and as I was preparing this presentation, I thought about telling you slide after slide about all the merits of doing this. The worst parts are creating the videos, by the way, and you do need to let go of that desire to control the classroom, at least largely. It's more like trying to herd a group of ducks. You're kind of constantly trying to keep them within certain bounds and on task, but there's a lot less control. The best are seeing those light bulb moments, as one of my GTAs put it, time and time again. The students, it's good to have these classes at the end of the day because they leave absolutely exhausted, because for 2 hours they've actually been using their brains and they are exhausted, and it is tiring to use your brain on a focused activity for 2 hours. It's really great for me with my diverse classroom to be able to go up and talk to the social psychology students in one way and kind of frame answers in a way that's good for them. And then I go to the quantitative students and they have completely different questions for me, trying to connect to other materials and being able to answer those questions for them. And it's very engaging. I'll say after 5 years of teaching the lecture, I could almost go off a script without really thinking about it. This was much more dynamic and much more tiring. And I was going to go on for this for many, many slides. But I thought it would be better if I let the students have a voice in this. So I contacted these students. I was able to find 26 of them back. Many of them have moved on, and it's a bit of a trick to find them back. But I got the 26 students and both GTAs. 20 of the students are still talking to me. If you're out there, hello. I did invite them to attend. I told them I would be on at this time in case they wanted to see what their other classmates said. And they were very, very generous. They gave me 22 double-spaced pages of homework. Thank you. incredible amount of response, and I tried to summarize this for you to give them a voice in this process. And one of the key questions I asked, it was two-sided. I told them, by the way, in administering this survey, I told them who I was talking to. I told them that their responses could actually change how quantitative methods are taught. I told them to tell me the good and the bad so that I could give it all to you. And the two key questions I asked were about the advantages and disadvantages for individual learning. I wanted them to focus on themselves and tell me what was good for them. And these are the themes that came up over and over again. Independently, 6 students talked about the ability to learn on one's own time or at one's own pace, that the hands-on experience and the application of statistics, that they very much valued that. 5 of them talked about they loved the ability to do what they wanted with the video. Skip over parts that they already knew, listen to parts that they didn't understand 2 and 3 times, stop it if they were getting fatigued, and come back to it again. 4 of them talked about they enjoyed the efficiency, not spending so much time on the missing semicolon or other programming issues. They loved having immediate help from, particularly for those who were working with R for the first time. That immediate help was very much appreciated. They enjoyed help from their peers, being able to talk within their group. They saw benefits to their group work, and they felt that it really pushed students, that it was a more intensive kind of practice than what they experienced in their other classes. There are a variety of other things that were mentioned. I'm going to make my cutoff 3 and above. You know, some say that it's less boring and it's helpful for shy students, perhaps, but I'm working with small samples here, so I'll cut off there. As for the disadvantages, this was the disadvantage that came up repeatedly. This is the one, and I will say, there were far fewer disadvantages discussed, or at least they were not discussed with a lot of regularity. The one that came up was your other group members can really shape your experience. If you work regularly with a group and 1 or 2 of the members come unprepared, it is annoying. It is frustrating. There were a variety of other comments that were made, and these are still important comments, but they were made by far, far fewer students, and they were made less regularly. Things like, it is frustrating to not be able to ask questions when watching a video, and some people felt that negatively impacted learning. Some people even felt that having to work in groups, that itself led to a lack of individualization. But again, these numbers are much smaller. What my graduate teaching assistants had to say, they said they saw lots of teachable moments. Students who would not typically ask questions felt more comfortable doing so. As a GTA in a reverse classroom, I never got to sit down. So I was tiring out my GTAs also, making good use of their hours. And in a lecture class, and this is an astute observation, a true negative, it's easier to catch up. If you miss a lecture class or you can't prepare before a lecture class, it's easier to catch up. If you don't watch the video before my class and if you don't attend, those interactions with the instructors are not replaceable. When was the last time you were called irreplaceable? I mean, it's that idea that, you know, if you're traveling, you can't just hand off the lecture to someone else and it'll get done. You've now become an irreplaceable part of your own course. The comment I wanted to highlight from one of my graduate teaching assistants, though, I think is closest to my experience, and I think one of the things I highly appreciate about this format. I believe that I saw some of our most ambitious and creative, and I should actually frame this a little bit. This person took the class with me, was my GTA in this class as a lecture format, and then was in a GTA in this class as a reverse class format. So he had seen this class for 3 years in a row. I believe that we saw some of our most ambitious and creative end of semester projects in the reverse classroom setting. For the lecture classroom, the end of semester project served as a demonstration that the students could apply the material. With the reverse classroom, students had already demonstrated their application of the material every time we met. So it necessitated them to strive for something more to show in their projects. Amongst the student quotes, And I try to be fair and balanced here. I think this is one of the stronger critiques that I think has to be thought about. I found video lectures to be less engaging than the in-class lecture, and the biggest con was that I could not ask questions mid-lecture. This is a cost. Along with, I could see that if you had a problem with domineering personalities, conflict, lack of communication, social loafing, groupthink, all of these would come to play, into play with a group, and they would decrease your individual learning. These were the two big negatives. Far less frequent. What I saw more frequently were comments like this. Being able to work through these difficulties, implementing the analyses, in class was extremely useful rather than sitting at home banging my head on the table or throwing my computer out the window. And even a few years out, I feel more competent in using and understanding categorical data analysis than I do other methods in which I completed coursework. And my favorite two, and then I will end. I found the reverse classroom puts a lot of responsibility on the student. If you don't spend the effort to make sense of the video lecture, then going to class would be a waste of time. This is not a bad system at all, and in fact, I found it to be preferable to a lecture-based course. I had this feeling that I had much more obligation to learn on my own, and I think in the end, I think that made me learn a lot more. Students feeling an obligation for their own learning. This is one of the comments that makes me feel like I did something right with this reverse classroom. The other one is this. I found myself challenged in new ways because I was faced with questions from my peers that you don't run into in a lecture class because there's no real hands-on opportunity to encounter them. For example, does this make sense? Does this have validity? Is this model working or not? How do we know? And this is why this is not cookbook kinds of questions anymore. Because now we are teaching a skill set that is essential to all quantitative literacy, a skill set that applies regardless of the method, that you have to be asking yourself those questions. And this is why I hope that you will consider, if not a reverse classroom, trying to incorporate some kind of deliberate practice into your classrooms. Some kind of tasks that require the statistical reasoning and problem solving to be engaged with regularly and frequently and with good support from you and your graduate teaching assistants. Thank you. So I went ahead and did screen capture. I also caught an extra bit of audio, and I brought it all together in a video in Camtasia and edited it down from 3 hours once I removed all the recap from last class, questions during class, material that would be taught as an exercise down to 1 hour. So I essentially had my same lecture materials, but instead of talking to them for 3 hours, I brought it down to 1. I will say that was the most painful part about this because for a 1 hour weekly video, it probably took me about 4 to 6 hours of preparation. So a 15-hour class, 60 to 90 hours of work on the videos. I've only done this with 2 classes. I would strongly recommend it's not good for a new prep because you need to refine the lecture first. But once that lecture is refined and you're doing it 1 more semester, why not just capture it while you're doing it? Why not do those high-quality video recordings and then be able to edit them the following year?
So how do you motivate the students at the beginning when they're not used to this to actually watch the videos?
From the comments, it sounds like sheer terror. 1 or 2 expressed anxiety, particularly about the quizzes. Having weekly quizzes in graduate school was unusual enough that it was anxiety-provoking. I think that after a few weeks and they realized that these quizzes were not aimed at being harsh, but trying to ensure, having watched the video, they calmed down. But I can see that it was, because it was a new format, it was anxiety-provoking, and I think at least 2 of the students in the disadvantages listed that it's unfamiliar, which is what you expect. That's to be expected. So, Leona, yes?
What level of graduate classes? It's not
No, it's a class that is typically taken right after your, I mean, we didn't have quite an ordering at KU, but typically they would take 1 or 2 intro grad stats classes, and then there was the option of taking this class. So it was relatively early on. We used Agreste's Introduction to Categorical, so the thinner version of the book. So it wasn't aimed at being a high-end quant class. Exactly. So this is where I would do all my usual lecture kinds of things, where I took the same material from the book and I framed it for them and gave them examples and gave them coding examples and kind of talked through the conceptual pieces behind those tests.
And that's where they got the content of the sessions in the video.
Exactly. Yes.